Yuma Lundi, this is Lau. Welcome. Thanks for joining us today to the public lecture organized by ALTA. ALTA is the Australasian Language Technology Association. Today we meet in Ngunnawal and Ngambri country, and I want to pay my respect to the elders past and present. ALTA is the flagship event in NLP and computational linguistics in the Australasian region. And today we are kicking off the 22nd edition of the ALTA workshop with a public lecture by Professor Eduard Hovy. Professor Eduard Hovy is the Executive Director of Melbourne Connect, a dynamic collaboration between leading organizations and interdisciplinary institutions aimed at leveraging research and emerging technologies to address global challenges. Eduard is also a professor at the School of Computing and Information Sciences at the University of Melbourne. It's an absolute pleasure to have here Ed today. Thank you. Ed is going to talk about large language models, what they are, and where they're heading. There'll be some time for questions at the end of his talk. Without further ado, please welcome Ed.
Thank you, Gabriela. Oh, it's okay, too loud? Thank you, Gabriela. It's nice to be here. Thank you for inviting me. I've never been to Canberra before, so to me, this is a really interesting. It sounds very loud. To me, it's very interesting to be here, to see this beautiful building and all the surroundings and things. I have to leave again tomorrow morning at 6:35. So I wish I could stay longer and just enjoy being here. So today, what I'd like to do is describe to you in not really technical terms what revolution, my understanding of the revolution that we're in now. It's not often that you live or that people have a chance to live in a peaceful revolution. The introduction 2 years and 1 month ago of ChatGPT brought generative AI to the world in a way that has moved faster through humanity than any other invention of humans has ever done, right? From zero, from not knowing to 100 million people. Something wrong here, I wonder. From going to, can you hear me like this? Or shall I use the other mic? That mic, this one is too. This one, good. Going from no knowledge about generative AI to having so many hundreds of millions of people around the world having used it can only happen because A, they can use it easily because it's English, right? And B, because it's interesting to them. It's got enough knowledge in there to be interesting. But there's a lot of problems in that and a lot of mistakes. And we need to understand, we NLP people have to understand what's going on and how we can bring this technology to the world in a responsible way. Otherwise, people are going to try it and they're going to make a mistake and it's going to lose money for them or something, and they're going to get angry, and then we get into an AI winter or a Luddite reaction, especially when generative AI starts killing people and starts costing a lot of money. Every new technology kills people, whether it's trains or nuclear or transportation, anything, right? And misdiagnosis and having all kinds of bad results of generative technology, generative LLMs, is going to happen. So we need to know what to do about it. I'd like to tell you today a little bit, an introduction sort of about what I think, what's happened and why and where we should be going. Okay? So this one, no? What's happening there? I'm sorry, this is maybe one time. Okay, so did anybody go to ACL in August in Thailand? A few people? So I saw this, about 60% of the papers that I saw, the posters, somebody says, look what my LLM can do. And I say, why? And they say, I don't know. I have no idea, but it's cool. And about 20% of the remaining of the papers said, look what my LLM cannot do. And I say, why? And they say, I don't know, who knows, right? And then there's a few diehard people like Roberto Navigli and others who say, I don't care about LLMs, I'm going to do my thing. And he had their noun phrase valences and all kinds of things. And I say, Roberto, why do you do this? Because an LLM can already do this. And he says, I don't care, I have no idea. So you look at this and you say, oh, come on, this is a bit of a problem here. How can we actually get to a point where we understand what's going on, right? Now, if there had been no LLMs and no revolution, in 10 years from now, you would have done this sort of work for research. You would have done some machine learning. You would have built data sets. You would have fought with everybody else about how good your algorithm is. You would have tried to make new evaluation metrics, all kind of stuff like this. And excuse me, I'm sorry if I'm insulting you, but to me, that is as boring as death. I stopped going to conferences 4 years ago because I found NLP so boring because it's just this. But now we have the new NLP. Now we have a machine and we can do all kinds of things with it, even though we don't know how it works. Nobody here can tell you exactly how this LLM works, right? But hundreds of people, even hundreds of millions of people are using LLMs every day. Suddenly our little field is becoming sort of mainstream, but they're not doing NLP, they're doing what you could think of as NLP light. So that puts us in the spotlight. They come to us, they say, I give talks like to industry 2-3 times a week now for the last year. They say, how does this thing work? What must I do? Help me, right? So are you sad or happy? What are you? Are you sad or happy about this? Is this a good thing for us or a bad thing for us? Now, I think what happened is if we look at NLP before ChatGPT, BC, right? And then came ChatGPT and everybody went into the veil of despondency and they said, oh shit, my thesis has gone down the toilet because I was going to do co-reference resolution and machine translation and poetry generation. And this machine can do all of that. I don't even have to program it. I just tell it in English and it does it, right? So I have to re-engineer my thesis. Most people doing a PhD felt that? No? Yes? Okay. So you go and you re-engineer your thesis and AD, after depression, then you come and you say, okay, there is 3 kinds of NLP, I think, 3 kinds of research. Number 1, there's the NLP engineering. These are the people who say, this machine costs a lot of money to make and it costs a lot. I want to make a small one. I'm going to make a fast one. I want to make an Arabic one. I want to make whatever it is. I don't care about all this linguistics and stuff. I'm going to do my machine, my training. I want to make it work with less energy and less whatever. Those are the NLP engineers. And there is one future for some of us to go and make these things just usable, right? Now, there are other people who say, I really don't care about that. I want to make my NLP useful. I want to take the gifts that I have been studying, the thing as a gift to the world and say, this is how you can use this machine. Whether you're in law or in chemistry, or whether you're somebody writing poetry, or you're a high school teacher, you can use this machine. People are using this machine. I want to learn how to make this machine useful for people. And there is lots and lots and lots of directions in there. And then there's people who say, I want to study how the thing works and what it tells me about language and about the mind and about knowledge, how that stuff works together. I want to make it understandable. That's where I sit. I'm one of the third people. But it's okay, right? We're all of us different. Different people have different needs and different wants, and we all have a space in this little map here. So what I would like to do, because I have only 45 minutes, I'm sorry, I will just tell a little bit about the first one, just one line of work in the first one. I will skip over the second one. There's a whole lot of things to talk about there. And I'll tell a little bit, 2 lines of work in the third one. Okay? And if you want more, I'm happy to come and visit, or we can do a Zoom talk or something. We can explore the other parts. I have lots more material to show. So we can either talk about research on LLMs or research using LLMs, or a bit of both. Okay, now let's look at the usable, the first one. Inside the first one, there are at least these kinds of areas. How to make LLMs, as I told you. There are people I can give you. I can send you a list of 72 steps. You want to make your own LLM and you have $500 million and you have a whole lot of computing somewhere. You can go scrape the web and take all of Wikipedia and stuff. I can tell you exactly how to do it. I can send you the instructions. But that's not us. I don't think anybody in Australia is going to build their own LLM. It's not going to happen. It's too expensive. You can go look at multimodality and start pushing in language and images and text and movement, robotic movement and things like this, and eventually emotions and so on, and maybe brain readings, so that everything gets encoded as an embedding and everything comes eventually into the same transformer architecture so that you have cross-modal influences. That's actually very interesting work that's coming. People are already working on that. That's not what I'd like to talk about. I'd like to talk about something called prompts. Everybody knows prompts. Prompts? Who wants to talk about prompts? Now, if you look at this little graph, which I got from the web, I don't know if I trust the y-axis, but I believe something like this is happening. A few years ago, when LLMs became big, before even ChatGPT, everybody was talking about pre-training. You have this LLM, and it's been trained on a lot, 2/3 of the English web, right? But he doesn't know your particular little bit of chemistry or your particular bit of motor car engineering or grocery or whatever it is. So you do the training on that. And you spend a lot of time because you want to take away all error and you want to make sure that there's no hallucination and so on. And then you write your little prompt, 2 sentences, and you get the results. And maybe it's not so good. And now you want to retrain some more. But if you look over the years, what's happened, the training has gone down and the prompting has gone up. And people today are spending, because it's so much cheaper and easier, a lot more time doing prompting than doing training. I think that is a very interesting and powerful phenomenon that we need to pay attention to. We people, we should start teaching how to do prompting properly. Do you know how to prompt properly? Have you ever evaluated a prompt? Do you know what the metric might be to evaluate a prompt? Don't you think that's an interesting question? No? So we need to do something about systematizing what you can call prompt space, the way that prompts can go, the way that you can make prompts, variations on prompts, how that works. Some people have tried prompt tuning, where they say, I take my prompt and then I put some kind of embeddings in of the domain words I want, and I make this kind of mixed modality type prompt, and then I feed it into my engine, and then it's got to run there, and so kind of tuning the prompt, giving it word sense type extra, almost like word senses, sort of extra embeddings. I think that's a lot of work. I don't think it's going to work so well. Other people look at prompt writing. OpenAI had this sort of little library of prompt kind of instructions, things like take it step by step, or if the answer is X, then do A, else do B. If you look at that for a moment, you say, that sounds to me like programming. No, doesn't it? Right, sort of English programming. Okay. If we take this seriously and we say no more prompt engineering, it's not engineering. Let's take it as a programming language. But the programming language that is now quasi-English, that has its own internal structure, which we have to discover. Some things work better and some things don't. That is run on a non-deterministic machine. It's not a von Neumann architecture anymore. It's now a neural network runs, and the thing changes every 2 weeks because the big companies make a new update every 2 weeks. What can we learn about writing prompts in this way that we can get out the results that we want? And how can we teach anybody? If you look in Canberra, how many people do you think know some programming language? 10,000? 15,000? 8,000? How many people do you think in the last 2 months have written a prompt? 500,000? At least one, probably 2 orders of magnitude more. And this is worldwide. Do you think the world is going to wait to do programming languages? Of course not. They're going to start writing prompts. They're already writing prompts. It's up to us to figure out how to write prompts properly. This morning, I had a discussion with one of my colleagues about teaching data structures for second semester undergraduates. We're talking about now about not even caring if they use ChatGPT to write their code or not. We want to teach them how to do the problem. We want to teach them the principles, and then they can reuse a prompt or they can write their program. I don't care. They didn't like it, but that was the line I was pushing. I think that's where we're going. I think 5 to 8 years from now, nobody's going to, it's like assembly language. Who can write assembly language? Show me, please. Can you write assembly language? One person, congratulations. Okay. Okay, that's what's going to happen. So I don't think it's only prompt engineering. I think what we're going to is going to a world in which prompts are going to become, prompting is going to become much, 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 much more important. So what do? I go to the web and I say, teach me about prompts. And I discover 4 months ago in Singapore, there was a conference where a bunch of prompt hackers got together and they had a competition and they had prizes and all kinds of things like this. And they tried to see what are the lessons we can draw from writing prompts properly. And they come up with something, a whole bunch of schemas. This is actually a very good guide to go look at. And this is the best schema I found. They call it Automan. It's like these 7 parts. So A is for act as. You tell the machine, dear machine, you are a professor. Dear machine, you are an expert in something. Dear machine, you are a this and that. You give it its persona, its point of departure, where it's coming from. Then you say, who am I? Who is the reader? I'm a child. I'm a Japanese speaker. I don't know about anything. I'm an expert. I just want an update. You have to tell it those parameters so they all go into the mix of how to take the right output. Then you must say, T, what do I want? What is the topic? What is my question? Give me the answer to my question. O is the output description and format. Do I want code? Do I want English? Do I want a bullet list? Do I want a slice text? Do I want a poem? Right? You have to give it those kinds of instructions. Then the M, the mode and the style, that's sort of the different language levels and so on. The atypical cases, the A for automat, the atypical cases, if there's something odd, here I'm telling you this is odd, so pay special attention to this case or that case. And then the cases I don't care about at the end is just ignore this, I know it already. If you write your prompt in this kind of style, you end up with a prompt that's about 1.5 pages. The prompt is not 2 lines. I know because I spoke to somebody from KPMG. I meet her and she says, I'm a prompt writer, prompt engineer 6 months ago. And I say, what's that piece of junk? She said, oh, no, it's a serious job. I say, I'm not interested in talking to KPMG. She says, I don't talk to people outside. I tell my KPMG people, they come to me. I write the prompts for them to get what they want to do. I say, teach me. She takes on her day off her laptop. She comes to show me. She opens the laptop. Her prompts are 1.5 to 2 pages long, every one. And she teaches me, you don't say, please. You don't say, please do this. You're not talking to it. You're talking to a machine. You say, I want, or you must. There are certain places you put a line break. You even put little stars. There are certain phrases you can put in, like, take it step by step, or it is important to me that. Now, why would that make a difference? But if you think of the training, in all the stuff it's read, if somebody says, it's important to me that I got a good score and so I did this and this, the weightings of that little phrase in the surroundings of the phrase, it is important to me, that had a certain different weighting, right? It's different words that come out to somebody who just said, I did this and this, without saying it's important to me. So when you say in your prompt, it is important to me, those words help to weight what words are selected to come out of the prompt. I'll show you how that works later on, right? So all the little tricks of these little phrases that you put in, where you want the boldface, do you want bullet list or not, they all make a difference. They all determine the kind of output we get. Our problem is we don't know what the systematicity is. We don't know how to work that. I think we absolutely need to learn to do this properly. Now, of course, at the same time, you'd like to evaluate your prompts, right? Any science is only a science when you can evaluate exactly what you're doing. You can metricize it. But we don't have a metric for prompts. I don't know how to measure a prompt. You give it to me. No. So I do know that a short prompt is better than a long prompt if the output is the same. Yes, you'd agree, right? I do know that if the prompt gives me an accurate response, not full of hallucination, then it's better prompt. I do know that if the prompt is complete, the output is complete, it gives me all the answer, not just the partial answer. That's better, right? So if I take a prompt and its output for a particular engine, and I do this many, many times, and I have different people write prompts and look at the outputs, I can begin to look at those two things, and I can begin to put together a set of metrics to come up with some kind of composite metric to say, this prompt response pair is better than that one, right? What I'm doing now with companies like Coles and NAB and other, I go to them and I say, let's have 2 days of holiday. Pick some problem, bring all your people, let's write prompts. Everybody, this is how you do prompts. Go off and spend the whole afternoon, and tomorrow morning, just have fun. Make your prompts. Come back, and then tomorrow afternoon, we write down, and everybody gets 20 minutes, and you tell me what you've done. And we put them up side by side, and we talk to one another. How did you get that? This thing is bad. What did you say in your prompt? How did you make this happen? What happens is we teach ourselves how to do prompts in our domain, in our area, and simultaneously we develop prompt evaluation criteria. Now, that's not difficult, right? But tell me it's not sensible. It seems to me so much more sensible and just obvious and real, the right thing to go do if we want to embark on a new kind of science, the science of prompt writing, prompt programming. This is what I think is going to happen. Whether or not we do it, whether or not we're going to continue teaching Prolog and Java and C++, go ahead. I'm not teaching that stuff anymore. I'm going to start teaching prompts now, because I think that's where the future is. Okay? So this is all this part about prompts. Okay, that's finishing the first part. Is okay? Yes? Okay, there's not much more to say. You have the idea. You can do it yourself. So point 2, making these things useful. There's a lot to say here. There's like 2 or 3 talks that one can have just on different ways of making LLMs useful. And one of them is, of course, you want the right information in, and so you have to worry about trustworthiness and hallucination and updatable knowledge and stuff. I mentioned a little bit more about that later on. You also want to make the knowledge tunable, so that a company can have its own knowledge in and another one can have its own knowledge in, and that's, as we know, RAG stores, right? But there's a lot more that you can do than just RAG stores. And so there's things about multimedia. If I give you a chemistry paper, you can't read the paper because you don't know the little chemical formula notation. But if I teach you that, which takes 1 semester to learn, it's called Smiles notation, you can, right? So I was in a workshop where chemists were trying to teach LLMs this notation so that the LLMs could read their formulas and read their technical papers. The problem was there isn't enough technical text in chemistry, or in mathematics, which has a different notation, or in physics, which has yet a different notation, or in architecture, right? Every field, if you think of it, has developed its own specialized notation to communicate what it wants to communicate. But none of those fields has hundreds of millions of documents to teach an LLM. But imagine you could. Imagine you could teach an LLM to read that notation and to begin to read a bimodal, a bilingual document where there's code switching between English and notation, English and notation. And imagine you could then put text, tables, graphs, all that stuff all together. Imagine you could mix all that together. Imagine how much knowledge, specialized knowledge, you could put into an LLM. And it could become useful for the scientists, and it could become useful then through them for the rest of the world. People are working hard on that already. We have some colleagues, Karen Hahn, who's doing multimedia document understanding. There's people all around the world working on exactly this problem. This is actually a very interesting problem, and it goes wide. We could work for 20 years just on understanding the communicative semantics of these different notations, the structure, the discourse structure of a scientific paper, how these things all work together. So there's a lot to talk about there. Okay, and then later on, tailoring to people's lives, that's a future topic. That's sort of more political and fun and social. So let's skip. So let's skip all this. Let's go now to point number 3, the understandability. Okay. When you want to make an LLM understandable, there are several topics too, and it seems to me it's a good way to break them down this way. You want to fix the problems first. You want to understand, why does hallucination happen? Why does this thing not know about truth? And how do I make it know about truth as opposed to just saying stuff, right? How do I update information? How do I timestamp information? I know now that soon Donald Trump will be the president, where it used to be Joe Biden was the president of the United States. Those are both true facts. It's just a different timestamp. How do I do that in an LLM? You cannot do that today, but it's a real problem. You want that if you have an updated knowledge base type thing, right? You can't even do that on the web today, right? So how do you do that? No. You also want to be able to make explanations. And there's a lot of stuff in there, which we'll talk about in a second, on how you can understand what an LLM does, how it works, so I can explain to you why it's doing what it's doing, so you can actually go and find out where the problems are. But you'd like to sort of overall, it's not a well-structured slide, but sort of you'd like to understand them. I would like to go into this understanding a little bit more. So I have two questions, just two questions that I'm wondering about. And I would like you to share, please help me. If you have any thoughts about this wonderings, please help me, please write to me afterwards, because this is the work that I'm now currently interested in. I would love to do work on, okay? Number one is, how does the reasoning happen? And number two is, why is the output so good? And I'll tell you those two things in a second, right? Why do they look as if they can reason? An LLM is just, it's like a knowledge base, right? Like BERT or something. And it's like a reasoning engine. It can program on top. You put the prompt in and it does some reasoning and it comes up with some conclusions. That was never programmed that way. And as you know, it's just putting together little phrases. Why does it look as if it's reasoning? What's happening there? How does it work, right? Well, the generative one has the chat loop on top. That chat loop produces multi-sentence output that seems to be coherent. It's better than my students' writing. It's better than my writing. How does that come from just putting together little phrases of words? Why? How does that work? If we don't understand that, the world is not going to understand that, and our science is weak. If somebody brings you a car and they say, it's a beautiful car, it is better than any other car you've driven, and you love the car, and you say, how does it work? Is it going to go off the cliff? And the guy says, I don't know how it works. Maybe it will go off the cliff. Would you buy that car? Of course you wouldn't buy that car, right? We need to understand, because that's our science. This is our field. Now, I want to go through 3 or 4 little slides, just background. You know all this, okay? What's a language model? In a phone, in your phone, when you type some words, it can predict, right? Why? Because inside it's got a little n-gram table, right? A bigram table for 2 words, or a trigram table for 3 words. That was developed in the 1960s and 70s for speech recognition. They just had these tables. If you were speaking to the microphone and somebody coughed or there was a noise, it didn't know what you said. It just guessed the most likely one, right? You build this by just looking at a lot of text and saying, given these 2 words, what's the most likely third one? So you never say the, but you might say the White House or the big man. And the White House is more likely than the blue house, right? Right. So it's simple to build this. Of course, when you have like 100,000 words in each column, 100,000 to the power 3 is a very big thing, right? So you don't have all of that in your cell phone. You have just a subset of that, of the most likely continuations. But that's a language model. It's just a set of words that allow you to tell what's the next one coming. What are the contextual words around your words? Now, when we go to a large language model, we take a transformer architecture, a little neural network like this. Let's say we take 5 million sentences with the word platform in. We hide the word platform. We create embeddings for all of them. We push the embeddings up, and at the top, we give, let's say, 200,000 words of English with names and things. And we want this machine to learn to predict platform from the 200,000 out of these sentences. Okay, and we do the back propagation training by putting the weights up and down, and we train all the little weights on the black arrows until eventually, for every word in English, let's say 200,000 words, we can predict, given a sentence, what's the most likely one that we hit, right? Right? That's the large language model. Okay, this takes 4 to 5 years. It took OpenAI 4 to 5 years to build ChatGPT this way, right? Cost $100 million or $500 million, right? And so it's not cheap to do. It took a lot of power, but this is what you do when you have one of these things. Now notice, in some sense, the definition of the word platform is those things. On my left, I have something to do with station. And somewhere to my right or left is train-ish words, and there's a the somewhere nearby me. And there's sort of location-ish kind of feelings there. it's not that those actual words are there. It's words that are sort of acting like those words. They all have the same distributional context. So it's words that are like platformish words. There's words like getting on or getting in or something like that. Those kinds of words that act that way have words around them too. So these, what you can think of as microfeatures, are like a little cloud of family relationships of words. I don't know how better to say that, but you get the intuition, right? So all you're doing when you're building a large language model is building for your 200,000 words of English, for everyone, a little cloud of the predictive microfeatures that when you say that word, it will tell you what's probably coming left and right. Or if you give a bunch of words, it'll say, well, probably they're all hanging around this word. That's what a large language model is, right? Nothing more, nothing less. So now it's a big lookup table. If I give you a sentence like, when was the Panama Canal built? The word then says, I've got microfeatures of time. I want something to do with time. Anything that's got time in it, you're a candidate for me. And then Panama Canal says, I'm Panama Canal. Anything that has to do with Panama Canal and the Pacific and the Atlantic and all this and the Panama, you're relevant to me. Thank you. And then built is I'm a building type thing. So I want words like construction and build and all that stuff. And when you put these three things together, those microfeatures together, you get this. What else can you get, right? It's simple, right? That's how BERT and all these big things work. They work through the intersection of these little microfeatures that you've learned. The same here for wood is to carpenter as stone is to, I have a material, I have a craftsman, I have that relationship. I have another material, give me its craftsman, here's the relationship. There's all these little microfeatures. That's it. That's how these things work. Now, it looks like reasoning. It smells like reasoning, right? Because when we do it, we reason. We think we reason. But it's matching little microfeatures just through a simple matching process. So yes, in that sense, you call that reasoning, right? But it's not deep. There's no correctness. It's just matching certain things based on what it's worth. It turns out now, if you look at how these little neurons go, there's something that some people call skill neurons. They have a certain specific representational power capability. So this guy met this guy, Wang. Where is he? His name is up there somewhere. Oh, he's on the next slide. I met him in Illinois. He's from Tsinghua University. And he wrote a very nice paper in EMNLP saying there's a certain configuration you can, for some concepts and topics, you can find little configurations of nodes that seem to be always active. They have a higher activation when those topics are discussed. Anthropic had a very nice paper about 6 months ago on Golden Gate Bridge. If you have a chance to go to the web and type Anthropic Golden Gate Bridge example, you see the movie they made. It's hilarious. It's one of the most funny movies you can see because they found this little configuration of neurons that sort of linked to Golden Gate Bridge. They artificially boosted its activation. And anything you did with Claude, if you say, what job should I do? It just says, you should be a painter of Golden Gate Bridge. Where should I go on holiday? You should go to San Francisco. You could see the Golden Gate Bridge, right? It was just trying to pull Golden Gate Bridge into anything, any word combination it could, because they were the active skill neurons for that case, right? So if you can get somehow a handle on these active sort of skill neurons, then you can begin to understand a little bit about what the reasoning is in a way that I'll show you in a second. So now we have some interesting questions that come out of this. Can we edit an LMM? Can we go in and say, I want to change what it knows? Can you do that? Can you go and sort of make it update itself? There's very interesting work by Hung Ji and this guy Wang who was there and so on at UIUC. And they have different strategies of editing. And I hid a lot of slides underneath here which describe more. I can send you the slides. You can see more about this. Second, on inference, can I somehow delete certain inference paths? Can I ablate them away and make it think differently? Can I delete everything else and force it to think some way? And there's some people there. There's a very nice paper that was in the conference Colm, C-O-L-M, in Philadelphia a month ago that does a survey of all this kind of thing, of this kind of work. It doesn't really work well. the top thing is not so clear what to do. So it's sort of difficult to figure out how to make this work. So I'd like to tell you a little bit about the reasoning chains. That's work I'm doing with one of my students now, and I'm really excited about this. The question is, how can I find a specific reasoning path? I've got my transformer. It's got, let's say, I don't know, 100 nodes by 12 layers, and it's got all this, and everything is represented in complicated ways with these micro features lying on top of one another, what's called superposition and so on. How can I find what it's reasoning, its individual little reasoning step when I give it a sentence? So here's what we did. We take these sentences called Winograd sentences. Anybody know what a Winograd sentence is? Yes? Look, it's a little, it's in the small letters I say there. I give you a sentence where there's one word I change, and it changes some interpretation in the sentence. So here's an example in the box. The city council refused to give the demonstrators a permit because they feared violence or because they advocated violence. Now, if I say they feared violence, who's the they? Of course, it's the city council. They're the ones who are fearing there will be violence. But if I change the word to advocated violence, who's the they? Now it's the protesters, right? Because they want the violence. So if I change one word there, the they is pointing to a different place. The co-reference goes differently, right? Now imagine I put this into my neural network. I take sentence one and I put all it, and I capture I make a photo and I capture all the activations. And now I clean it all. I start again and I take sentence two and I put that, and now I take all the activations. What do you think I find? I find that almost everything is identical. So the numbers are almost all the same, except for those two words and where the they is pointing to. Right? So in this way, you can do diagnostics on this because you can wash out all that complexity because you've got two sentences that are almost identical. It's a clever trick. That's a clever little trick there. So here we have, this is just what I said. And so here's a little graph called a flow graph. That's on the left, on the bottom. These are the words of a sentence. There's the sentence on the top. In the hotel laundry room, Emma burned Mary's shirt. So the manager scolded or reimbursed Emma or Mary, right? Another of these sentences. So you can see the words coming in and then going up on the y-axis, you can see the layers, and you put a threshold cutoff so that any activation that's below a certain threshold, you don't show him, it's too much noise. And you just see the little green dots there showing which words sort of have a high activation level that persists up to a point. So when you do the two together, there you see Emma up there on the top, and then you see Mary, and here's the word scold, and scold points better to Emma than to Mary. There's words that try to point to Mary, but ultimately the Emma link wins. This is not a very nice notation. It's awkward to work with. We're going to try to make a better interface and ways to control this stuff. But it's a way of looking inside the neural network and washing out all that complexity and the noise of a million microfeatures to get just what you want, just that little thing you want. Yes? This is an interesting thing to do. Now, there's lots of complexity here. If you put in the threshold too low, you get too much noise. If you take other kinds of sentences, I saw her skiing on the lake. What was she wearing? I saw her skiing in the Alps. What was she wearing? Right? Alps and lake is the variation word. The prompt, what we call, or the probe, what we call, is what was she wearing in this case. We're trying to collect sentence pairs that are minimally different with one sort of probe instance in there so that we can do this kind of diagnostics, this kind of almost surgery, because I want to be able to go in there and identify the particular point of interest, the particular activation path, and then I can go do surgery. Because if I can do that, I can then go in and I can say, you don't like the ethics of something, you don't like the thing to be racist, you don't like the thing to be sexist, I'm going to cut out the links to those pieces, those little pieces, those skill neurons, the reasoning paths that lead there. And then I will be able to give you a better guarantee that this thing is ethically good, rather than I just did human reinforcement feedback learning like OpenAI does by paying people in Kenya $2.10 a day for months, right? And then praying that anything bad doesn't come up. right? You want to do something more scientific and substantial, and I think this is an interesting way to do it. But I don't have a good way of doing it yet, so I ask you, if you have a better idea or suggestion, let me know. This is what we're trying to do now with this one student. Okay. So there's the experiments we're running on Llama 3 and blah, 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 all kind of things you can read. I send you the slides. Now, just coming to the last bit, and then I have to stop, unfortunately. I would like to wonder with you, why is LLM generation so good? Have you ever thought? It's amazing. It's better than we are. Now, oh, sorry, this is the wrong way. If you look at this, how does an LLM generate, a generative LLM? You give it a prompt. There's a bunch of words in there. As we know, this goes into the transformer. The microfeatures of these words pull out other likely words. And here are some possible sentence fragments that get matched. I pick one. If the temperature is 1, low, right? It's always the first one. I always get the same output. If I put the temperature higher at random, I pick anything. That's why I get different outputs for different things. Okay, there's new words there. I go and match again. Here are some continuations. I pick that one. Why not? At random, anything that nicely continues my next one. Oh, there's some new words. I pick new ones. I keep going left to right, and I just keep going. Just keep going. Just like my 10-year-old daughter. There's no reason to stop. I just keep going, right? I just keep talking left to right. Everything reminds me of something else. Notice, of course, that there's no guarantee that the words coming at the end of the sentence are connected to the words in the beginning of the sentence. That's called hallucination, right? That's what hallucination is. It's just making things up that seem to fit in the local context. I don't care what the early context was. So hallucination is an obvious problem. It's just what I told you. But how do you get, you still get some kind of coherence. How does that work? You still get some formatting, consistent formatting. You get a bullet list that continues with bullets. It doesn't somehow stop bullets and then start bullets in the middle or something. How does that work, right? Why does the thing stop speaking? How does that work? Think about it. You've never probably thought, or maybe you have thought about this. These are interesting questions about how these machines work, that if we understand them, we can talk about understanding these machines. I tell you, I've looked. There's almost no literature on this. I don't know why people don't ask these questions, but I think these are really important questions to be asking. Now, if you go to GPT-2, which was the big famous one before GPT-3, before ChatGPT, here is a famous example that they published. This was the prompt. In a shocking finding, scientists discovered a herd of unicorns living in a remote, previously unexplored valley up in the Andes Mountains. Even more surprising to the researchers was the fact that the unicorns spoke perfect English. And then the machine continued. The scientists named the population after their distinctive horn, Ovid's unicorn. Now, why Ovid? Ovid was a Latin poet. What did he have to do with this? Nothing. No? These four-horned, excuse me, a unicorn or a four-horn? Excuse me, right? You see the hallucination creeping in, right? Silver white unicorns were previously unknown to science. Now, after almost 2 centuries of what? Since when? All right? The mystery of what sparked this odd phenomenon is finally solved. Dr. Jorge Perez and blah, blah, blah goes along and he talks about all this. There's a natural fountain and they climb the mountains. And next, Perez and the others ventured further into the valley. By the time we reached the top of one peak, the water looked blue with some crystals on top. So they're going into the valley and then they're on a peak. Right? And now the next paragraph, Perez and his friends were astonished to see the unicorn herd. These creatures could be seen from the air without having to move too much to see them. So now they're on the mountain, they can see the creatures down there. In fact, they were so close they could touch their horns. Now, how long was their arm? I mean, right, you see, there's no logic here, right? This thing is just full of crap. But this is the thing they published, and they said, this machine of ours, and it's great, and it's going to take over humanity. This is the quality of the rubbish that people in the world believe is going to take over humanity. No? Now, today's LLMs are better than this, but they still have the same kind of problem because they work the same way, right? So it's up to us to figure out what's going on here. Okay, now when you make a text, as you know, because we're all academics, right? You need to know what you want to say and why you want to say it. And so when you have a complex multi-sentence message, you actually have to plan your text a little bit. Any child can speak grammatically because it's unconscious, but every child has to learn in school how to write coherently a multi-sentence document because that's conscious, that's not unconscious. Untrained writing is a mess, as we all know, right, being academics. So when you start with your little network of concepts like this, it takes a lot of time where you sort of break them up and say, here's my main sort of topic groupings, and then I want to make this one and that one leading to there and there and there, sort of like this rhetorical structure type tree, and I want to put in these discourse connectors to tell the reader who's getting a linear one-dimensional sequence of words, what's the two-dimensional organization of my network here? Right? That's the function of these little words. That's the function of this discourse structure. It doesn't happen automatically. Now, bear in mind, LLMs, how they work, right? It's just going left to right, right? There's no planning like this. At least that's what people say. No? So it does make a difference what you say first. If I give you the two sentences in the box, X was a big problem for them. They did ABC, but eventually they did solve it. Or X was a big problem for them, but eventually they did solve it. They did ABC. To me, the implication is after solving it, they did ABC. Now that's the solution. Whereas for the left side, it is they tried A and B and C, and one of those things worked. To me, there's a very clear difference between that ordering there. That doesn't just, you can't just randomly pull things together because they happen to work together. No. You have to have certain things. So one of my students did a little classification of the different ways that you can do LLM-based generation, top down and left to right and stuff like this. There aren't any other logical possibilities. But when we go to ChatGPT, and I tried this, and you can try this too, and I said, please tell me how to make tea. Tell me how to make tea in 6 steps. It wrote to me 6 steps, beautiful, how to make tea. And they said, now tell me how to make tea in 10 steps. And it wrote to me how to make tea in 10 steps. Beautiful, and it was right. Now, how did it know how to unpack the 6 or the 10 or the procedure into 6 exactly and 10 exactly? And I bet you if you try 7 or 12 or 9 or 3, it will tell you, and it'll all be beautiful. I'm asking you how it knows that. Would you be able to do that? If I tell you, please tell me how to make tea in 6 steps, start now, right? Don't think, right? Can you do that? You can't do that. Of course you can't do that. Why can this thing do that? Because remember, it's just doing left to right sentence extension. There's something else going on, or is there something else going on? What's going on here? I think that's actually a very interesting clue or a clue to some very interesting understandings of what's happening inside this machine, inside this generative architecture. So the best I can think of, either it's learned some kind of schema templates, and these templates include bulleted lists and enumerated lists and list length 6 and 7, and it's got sort of a micro feature bundle for a template of 6 steps and another micro feature bundle for a template of 7 steps. Not what's the content, but what's the structure. Or there's some kind of hidden inner loop that they're not telling you, that they're just doing, and it's this sort of planning, it's pulling stuff, and then there's an inner loop of planning it all out. Or it's doing all of this in one shot. It's sort of planning its structure and its planning. It's all carrying this together. It's sort of got the content tiling going on, the little words coming. And at the same time, it's got sort of formatting instructions, unpacking itself. And just as the micro features for the words are governing which words come out, the micro features for the formatting also unpack themselves and make them go. And then they sort of come, I need to stop my sentence. I really need to stop a sentence. Now I can stop a sentence, right? So there's the formatting control and the other one. I don't know today what is going on there. It may be, I don't believe number 2. Some people tell me that number 3 is the right thing. If you go look in the literature, you don't see much on this. I have never seen, and I've asked ChatGPT how it does its own generation. It has no idea how to introspect and tell me. I've asked some scientists and people who work on this. Nobody can tell me. If you can tell me, please tell me how these things work. It's not a difficult question. How can that thing tell you T in 6 steps or in 10 steps? It's an easy question. Anybody can understand it. But the answer is not easy to get out of this machine. So please explain. Okay? So here's some schemas. I'm almost finished now. Here's some schemas. In early ChatGPT, if you told it it was wrong, it would say, yeah, sure. Oh, you're right. Okay. That was the schema it had, or that had the pattern. When the user says in the prompt, you are wrong, then it sort of learned, okay. Today's ChatGPT says, oh, no, sometimes you're wrong. It disagrees with you. It's quite willing to disagree with you. And there's, so here's an example of, oh, where are we? Sorry. Okay, let's skip. Sorry, let's go back. Just one example. Oh, I'm going the wrong way. Oh, okay. There. This one. Let's just do this little example. Here, I tested this. This was an example that was developed in Queensland, I think, a few months ago. Of the 52 countries in the EU, only 2 start with B. And the thing will look and it'll say, that's correct. Among the 27 European EU members countries, only 2 of them start with B. So it has corrected my 52 to 27, but it didn't tell me there's an error, and it tells me the 2. And then I say, of the 52 countries in the EU, only 2 start with D, and then it says, actually, there are 27 member states in Europe. Now it does correct me, right? Not 52. As of my last count, there was, among the 27, only 1 of them starts with a D, so now it's telling me Denmark. So what's going on? Is it 2 templates coming up? What's happening inside there to make these 2 differences come out? What's interesting to me is that the NLP community is not asking these questions. The NLP community is running around saying, look what my LLM can do and I don't know why, or look what it cannot do and I don't know why. That is stupid blind search. Questions like this that make you wonder, why can it do or not do simple things? And tell me how, and do this little investigation into its reasoning patterns, into those chains. That's interesting work. That's NLP work of the future, I believe. We have a new tool. It's called the Generative LLM. We're not going to ignore that tool. We're not going to go back to writing software code and things like that. We're going to use this thing so we better understand it. Okay? So here's some topics. Are there schemas? How does long distance generation work? And so on. Is there an inner loop? Okay? Now, quickly conclusion, then we stop. Given all this research, we're in a larger context of the world, and the world says, yes, you little researcher, you can go and do your thing, but we want to use this machine. And in fact, we're now starting to see what's called agentic LLMs, where LLMs are trained to do specific tasks. This one knows about travel agency, and this one knows about bank accounts, and this one knows about something else, and about diet and all this kind of stuff. And so pretty soon, you'll be able to say to your machine, okay, I want to go to somewhere, New Zealand, for Christmas holidays. Book me the flight, book me the trip, make the trip. And tomorrow you wake up and it's all been done for you, everything. And if you give it access to your bank account, it'll even pay the money. Now, you may not like that, but that's coming. No? I predict if we go to the next step is autonomy, where it has its own goals, where it says, oh, it's coming toward Christmas. You need a holiday. You've been working too hard. I'm going to book for you a holiday. It's now I'm running by myself. I got my own goals and things. You think that's a joke? You think that's not going to happen? I predict before the end of this decade, all of us will be paying Telstra $100 or $500 a month from through the cell phone to the cloud, where you will have your own personalized little chat engine. And it will know your bank accounts, and it'll know your family's birth dates, and it'll know your food preferences, and it'll know all kind of stuff about you. And you will talk to that thing as if it's your deepest friend, and you will tell, and it'll probably even listen to all kind of stuff you say, all your conversations, if you let it. That's going, you tell me I'm wrong? Really? You think that's not going to happen? 15 years ago, I was in Tokyo. I visit NEC. They showed me a little movie. There's this little lady, little grandmotherly lady, and in her kitchen, in a tiny little flat in Japan, on top of the fridge, there's a little white domed thing, and the thing had 2 behaviors. It said, if there's nobody around, no sound. And if there's people walking around and talking, it said, makes a happy noise. And they asked this lady, you paid some money for this thing. Do you like it? She said, I love this thing. I said, why? I mean, it's a little machine, and it's only got 2 behaviors. She says, it pays more attention to me than my husband, right? Now, if you can put your emotion into that stupid little machine, and this is what people do, how much more are you not going to put your emotion into things that sound, that you can talk to at 2 in the morning, that never criticize you, that book your holidays for you, that listen to your program? You're not going to like it. I was talking to a reporter from ABC 2 days ago, and this guy said he's been doing studies on how many of these companies there are that are building emotive-based chatbots and things, and they're even embodying them into robots, into shapes. We're all going to have something like this. Last year, a colleague, a psychologist, and I published a paper. We took papers from Dear Abby, you know, the agony aunts. We took 10 different agony aunts, each one 10 questions with the answers that they wrote. We took those 10 questions and had ChatGPT, simple 3.5, write answers, the same length answers. And then we scrambled them and gave them to a bunch of readers and said, which answers do you like more? And we counted. About 62%, the preference was for the machine-generated answer. Why? Because it was more empathetic, it was more friendly, whatever. They said things like this. Then we took this back and we went back to them and said, do you know that half of the things you've seen were made by a machine, by a generative machine? Can you guess? And they guessed, and they could guess more than randomly. Just over 55% they could guess which is the machine. And then we asked them again, now tell us which one you like more. And they still preferred the machine, more than half. All right, there's something about the empathetic attitude of this word continuation thing, and nicely written, which is always there and not threatening and stuff, which is just attractive. We suspend our disbelief. We don't care. As humans, we just want that emotional connection, even to the fridge thing, even to ChatGPT. That's going to come. So again, it means we NLP people have a beautiful opportunity to study this stuff, to make it work, to bring emotion in, to bring proper guardrails in, and so on, right? We have to understand how it works, and we have to know how to unpack it properly, to bring it to society in a way that is responsible and helpful and good for people. We are moving away from blind and stupid machine learning into a very rich area. We are lucky, I think. That's it. Thank you very much. There's the future.